So now we're ready to start focusing on what the graphs of these polynomials actually look like. And today, we're going to pay attention to what each end of the graph looks like. So that's referred to as the end behavior. And our objective in this video is to be able to describe the end behavior of any polynomial. So when we think about graphing lines, the most basic line that we know how to graph is the line y equals x, or some variation of that line. You've been graphing this equation for a very long time now. So this right here is what the equation y equals x looks like. So this is in slope-intercept form. And this x has an exponent that we don't typically write, but it's an exponent of 1, and 1 is an odd number. That means that if our equations are in standard form, and I look at my largest exponent, any of the odd exponents are going to behave somewhat similar to this. Now, the higher the power goes, the more sort of wiggles or curves that are happening between here and here. But at the end, if the exponent is odd, it's essentially going to look something like this. If the leading coefficient is negative, then my graph, instead of going this way, would be mirrored so that it goes this way. So this would be the graph of the line y equals negative x. So my exponent here would still be a 1. So if the equation is odd, then it's going to follow this basic pattern. So these two are my examples of if my exponent is odd. On the left is when it's positive. My leading coefficient is positive. On the right, my leading coefficient is negative. So these are both odd. This one is positive and odd. This one is negative and odd. Now we're going to talk about when our exponent is even. So the most basic one we have here is x squared. So if I were to graph just what y equals x squared looks like, this is back from our conic sections or when we were doing quadratics. This is sort of a sloppy version of it. But it looks something like this. So this would be the equation of y equals x squared. So here our exponent is an even number. If I were to make it y equals negative x squared, then it would just be a mirror image of that. So that would go this way. So this one would be y equals negative x squared. So these two are examples of even. This one on the left is our positive even. This one on the right is our negative even. So if your exponent is even, it's going to follow this same basic idea. Again, the higher your exponent goes, the more curves or wiggles that your graph is going to have between the two endpoints. But at the end, they're all going to behave in one of these 4 categories. So the way that we would describe the end behavior here, this one falls left and rises right. So if it's pointing down, it's falling. If it's pointing up, it's rising. This one rises left, falls right. Over here, this one rises left, rises right. This one falls left, falls right. So that's how we're going to describe our end behavior. You're basically going to have 2 parts. You're going to have the left and the right, and then you're going to say whether it rises or falls. So here's our first example. Our leading coefficient here is a 1, a positive 1, and our exponent is odd. So you're going to think back to odd and positive. That's kind of the rough idea of what your picture should look like. So this one is going to fall left, and it's going to rise right. So this is how we would describe our in behavior. So on your homework, that's what you're basically going to write. Falls left, rise right. On this next one, this one is going to be even. It's in standard form. Our exponent is a 4, so that's an even number, and it's negative. So think back to what that one looked like if we go back to it. That one's going to be an example like this. So it falls left, falls right. So that's what we're going to write for this one. Falls left, falls right. So this one is odd and negative. So that means if I think back to what it looks like, this one is going to rise left, and then it's going to fall right. And we'll do one more example. So this one, if you were to try to graph this, you wouldn't even be able to see it on your window because the exponent is so large. But it doesn't matter. We're still focusing on even or odd and positive and negative. So this one is even and positive. Since it's both even and positive, it's going to rise right, and it's also going to rise left. So we just went through 4 different examples, and that pretty much covers all of the 4 different categories that you're going to see. So you're just breaking it down into one of those 4 groups. It's even or odd, and it's positive or negative. So the homework to the right, you're going to write statements that look like this for each of those problems.